example 3. This is probably the last thing we'll be able to finish before class. If you haven't watched the videos, try to watch these last 2 parts before we meet again on Thursday. I want to spend all Thursday when we're in person working on problems so I can see how you're doing, because honestly, right now I have no idea. So what does example 3 say? Example 3 says you want to find a linear approximation of this function at x equal to 0 and use the approximation to approximate each of these things here. So we're going to follow the same strategy that we had earlier. In this case, our a is equal to 0. Our f of x is going to be equal to 1 plus x to the n power. I know I need to calculate the derivative. F prime of x is going to be n times 1 plus x to the n minus 1. When I put my a value in, what's going to happen? Well, if I calculate what f of 0 is going to be, that's going to be 1 to the n, and 1 to the anything is just 1. My f prime, I want f prime of 0, that's going to be n times 1 to the n minus 1, and that's just going to give you an n. See, this question is kind of weird because they don't tell me what the power is, so I just have to leave that as a variable. Okay. Now I think I have everything I need to write my linearization formula. So my linearization, again, that's just a tangent line. That's going to be f of a plus f prime of a times x minus a. In this case, f of a, that's f of 0 plus f prime of 0 times x minus 0. And for us, we could see f of 0 was 1, f prime of 0 was n, and x minus 0 is just x. So we did all that just to get this very simple looking linearization formula. Question asks why, some student asks why is f prime of 0 equal to n? So I calculate the derivative right here, right? F prime of x, you bring down the n in front, it's 1 plus x to the n minus 1. Now when I plug in 0 for x, I'm going to get 1 plus 0 is 1 to the n minus 1 like this. But 1 to any power is just 1, right? So really this is just n times 1, which is equal to n. Does that make sense? Okay. So let's say I want to estimate 1.01 to the third power. This is telling us x is equal to 1.01 and n is equal to 3. So that's basically going to be L of 1.01 is just 1 plus 3 times 1.01, which is 4.03. For this last one, we want to estimate 0.99 to the fourth. So that's going to be L to the 0.99. So you're going to have 1 plus, because it's to the fourth power, the n is 4, right? X is equal to 0.99, n is equal to 4. So you just got to plug in those two numbers there. And when you do that, what are you going to get? 4 times 0.99 plus 1, 4.96. So each of these guys are our approximations. Does anyone have any questions about these examples here? No? All right, cool. So